itself. It's just not worth it. Plus, once you get to actual functions that involve logarithms, you almost always stick to 10 and e.
Oh, okay.
You really do. You transform it. If it's not 10 and e to begin with, you change it, and then you use it that way. So why bother? Okay, so let's say you want to ask your calculator, what is 10 raised to the log, and your calculator will assume that means log base 10 of 12. What do you get? 12. I would expect that raising 10.
So 10's the number.
If you don't see anything else, 10 is the base.
10's the base. Oh, and 12 is the number.
Yeah, 12 is the number.
Oh.
So what this property illustrates is that these are inverses of each other, like addition and subtraction, like multiplication and division. They cancel each other out. It just looks more confusing when they do. You can fiddle with the calculator to help show that. Because they're inverses of each other, that also means they have inverse graphs of one another. Okay? And I'm going to use some technology for this one. I'm not going to do this one by hand. Okay, so...
Wait, so you're assuming that in the bottom one that log is 10 or log is...
Yeah, if you don't see anything, it's 10.
And 12 is what?
12 is the number. Let's see, if we rearrange this statement, if we were looking at log base 10 of 12 equals blank, and I don't know what that is, this is the same as saying 10 to the what power equals 12.
Still 12.
Yeah, that's because we're setting it up here so that the 10, raising the 10 to the power and taking the log base 10 cancel each other out. When you set it up this way. Because they're inverses of each other. Some of this I'll explain in more detail tonight. I'm actually asking you guys to really just practice manipulating some things so you'll have better understanding of the explanations.
Graphing tonight?
There'll be some graphing tonight. I'll go over that right now. One sec here. All right, now. Okay, a couple things. First, we're talking about inverse functions. Real test of memory here. Who remembers? Okay, inverse functions, I said, are always reflections of each other about a certain line. Anyone remember what that line is? Asymptote is the line that certain ones snuggle up against.
Y equals X.
Y equals X. Excellent, Layla.
Thank you.
They're always reflections about, come on, computer. And if you have inverse functions, they're always reflections about this line. Now, this is another thing that makes sense, okay, with this. If we graph, let's just say y equals, let's do 10 to the x. What do you guys know this should roughly look like? Y equals 10 to the x. Make your little table, x, y. What three numbers do we plug into y equals 10 to the x?
Negative 1, 0, 1.
Negative 1, 0, 1. And we're going to get what three numbers here?
1/10, 1 and 10.
What James said.
0.1, 1, and 10, or as Dean said, what James said. Okay? So then I graph these two.
I mean, I was right.
All right. Now, take a look at this. Okay? Here's y equals 10 to the x. Here's y equals x. One reason why people were pretty sure something like logarithms existed is because this function here, the logarithm one, looks like it should have an inverse. Okay? It passes the vertical line test, but it also passes a horizontal line test, which means its function should have an inverse that's also a function. All right, so people look at, but no one knew what to call it because they couldn't figure out how to do exponents backwards until Napier. So now, if we look at the logarithm, y equals log x. I don't have to write the base 10 in. I don't have to write the base 10 in, so Do these two graphs look like they're both reflections about this one?
Yes.
Yeah. Let's check the corresponding points. James, you said this should be -1.1, right?
Yeah.
Okay, does this graph look like it has a point down here, which is 0.1 on the x, -1 on the y? Okay. The original function passes through 0, 1. So the inverse function should pass through what corresponding point? 1, 0. The original function also passes through 1, 10, which I have not left room for on this graph. So its inverse should pass through which point?
10, 1.
10, 1. Things looking good for the home team?
Yep.
And that corresponds to 110, which would be somewhere up there. There it is. Okay.
Really?
Thereabouts. I don't know.
You sure about that?
No, I'm actually not. But actually, I think that's pretty close.
It's kind of off.
You're right on the wall.
Oh, come on.
Near to the left.
How do you know?
All right.
All
All right. That's actually better than I do when I don't leap in. Anyway. Now here's my actual recommendation for graphing these, especially since your calculator, it's a real pain to graph anything but base 10 and base e, logarithms. Okay, your calculator will naturally do that. If you want to graph anything else, you have to put the change of base into the graph. That's not actually what I want you to do tonight. On the graphs of logarithms, they're in your homework either tonight or tomorrow night. I'm forgetting which now. What I want you to do is, do this table for the inverse. Okay, do this table for the inverse. Figure out these points, and then switch them to graph the logarithm. Does that make sense? Okay, so let's do an example of that. And we'll put it up there in a sec. Okay? If you're asked to graph y equals logarithm base 5 of x. Okay? What is this the inverse of? 5 to the x. This is the inverse of 5 to the x. Okay? On 5 to the x,
So you just take the log add and get the inverse?
well, yeah, yes, basically, yeah. What are the three interesting points on 5 to the x?
-1, 0, and 1.
-1, 0, and 1. What do we get when we plug these in?
1 over 5, 1, and 5.
1 over 1 and 5. 1 over 5 is 0.2. You know that your calculator can tell you. So the points you graph on y equals log 5, you would graph, instead of -1.2, you would graph 0.2, -1. Instead of 0, 1, you would graph 1, 0. And instead of 1, 5, you would graph 5, 1. And that's how you would start the graph of y equals log 5 of x. This graph here, the original graph, the exponential one, it has an asymptote of the x-axis. What do you think happens on the logarithm? The asymptote is the y-axis. It's snuggling up to this vertical line.
So you graph the ones from the log, right?
Yes, you graph the ones from the log to that
Right.
one. Sometimes it's helpful to graph both and make sure you're getting a reflection. Okay? Double check something here. If the graphs are on tomorrow night's homework, then I won't go any farther with this. Okay, we'll talk more about graphing tomorrow. The homework is, good question. Homework is page 490, 16 to 46 even. 16 to 46 even, and I may go over another example from that, but Cody